Today's lesson is 8-5, day 1, and our objective for today is to be able to factor the difference of two squares. These are all perfect squares, and you're going to have a handout that has these on there. If we look, 1, 4, 9, 16, 25, 36, all of these are what we consider perfect squares, meaning that we can take one number and square it and get that number. Or if we take the square root of it, we end up with a pretty number and not a decimal. A polynomial is the difference of two squares if there are two terms, one is subtracted from the other, and both of those terms are perfect squares. Here's my rule for that, and I want you to go ahead and write the rule down on your paper. You're going to write a squared minus b squared equals a plus b and a minus b. So go ahead and take a minute, pause the video, and write that rule down. Here's an example of this. You don't have to write this one down. We're just going to talk about it. You'll have plenty of examples to write here in a minute. If you notice, 4 is a perfect square, x squared is a perfect square, and so is 9. And it has a minus sign in the middle, so it fits the difference of perfect squares. So I can split 4x squared into 2x and 2x, and 9 into 3 and 3. And with my rule, it says you have a plus sign in one and a minus sign in the other. So we're going to say 2x plus 3 and 2x minus 3. But again, first term has to be a perfect square, last term has to be a perfect square, and there has to be a minus sign in the middle for this rule to work. All right, go ahead and write down number 1, x squared minus 9. Alright, so up until now, if you've had a binomial, the only thing you've been able to do is take out a GCF. And we still need to look for a GCF first, but there's no GCF of x squared and 9. But now, after you look for a GCF, you also need to look to see if it's a perfect square. So we look at the first term, x squared is a perfect square. We look at the second term, 9 is a perfect square. And we also look to make sure that there's that minus sign in the middle, and there is. So this goes with the difference of perfect squares. So I can still factor it. So I'm going to split my x squared up into x and x, and my 9 up into 3 and 3. And if I'm not sure if 9 is a perfect square, I can look at that handout that we gave you, and you can see that 9 is a perfect square of 3, because 3 times 3 is 9. So 9 is a perfect square. That's where I got my 3 and 3 from. Again, my rule says that there's going to be a plus sign in one and a minus sign in the other. So since I have x and x, those are going to be my first term here and my first term here. 3 is my second term, so it's going to be my second term here and my second term here. And the rule says a plus in one and a minus in the other. So I just factored x squared minus 9 into x plus 3 and x minus 3. Now we're going to go through and check it. And we won't check all of them, but I do want to check the first couple. Alright, so when I go to check this, I say x times x is x squared. And then I say x times negative 3 is negative 3x. Then I say 3 times x is 3x. And 3 times negative 3 is negative 9. And then if you look at the two middle terms, you have a negative 3x and a positive 3x. So those are actually going to cancel, which is exactly what they should do. That's why you have to have a plus sign in one and a minus sign in the other. And I'm left with x squared minus 9. And x squared minus 9 is exactly what I started with, so it checks out. Please make sure you have the work and the check written for number 1 before you move on. Okay, go ahead and write down number 2. Number 2 says 25 minus 4x squared. So I have a binomial here, so the first thing I need to do is look for a GCF. So if I look on my factor sheet at 25 and 4, there is nothing other than 1 that 25 and 4 have in common. They don't both have x's or anything. So I can't pull out a GCF. So then since it's a binomial, I'm going to look to see if it's perfect square. So I have 25 and 4, and if I need to, again, I can check my list. 4 and 25 are both on my list of perfect squares. 4 is 2 times 2, or 2 squared, and 25 is 5 times 5, or 5 squared. So they both are perfect squares. There's also a minus sign in the middle right here. So this is the difference of perfect squares. So I'm going to split my 25 up into 5 times 5, and split my 4x squared up into 2x and 2x. Again, I know that there's going to be a plus sign in one and a minus sign in the other because of my rule. Here, 5 is my first one, so it's going to be my first one here and my first one here. 2x is my second one, so it's going to be my second one here and my second one here. So I just factored 25 minus 4x squared up into 5 plus 2x and 5 minus 2x. So now we need to check. So when I go back to check, 5 times 5 is 25. 5 times negative 2x is negative 10x. 2x times 5x is positive 10x. And 2x times negative 2x is negative 4x squared. Oops, there we go. Now you can see it. Minus 10x and positive 10x here are going to cancel, so I'm going to go ahead and mark those out. And I have 25 minus 4x squared, which is exactly what I started with. So I know that I factored that correctly. So this is my final answer right here. Please make sure that you have the work and the check written for number 2 before you move on. Alright, go ahead and write down number 3. Number 3 says 16g squared minus 81h squared. So again, my first thing is I need to look for a GCF. So if I look at 16 and 81 on my factor sheet, the only thing that they have in common is a 1. So they don't have a GCF. Also, the 16 has G's and the 81 has H's, so there's nothing that they have in common as far as letters there either. So there is no GCF here. So then I'm going to look to say, okay, is 16 and 81 both a perfect square? So again, if I don't know for sure, I can look back at my factor sheet, and 16 and 81 are both on my perfect square sheet. 16 is made up of 4 times 4, and 81 is made up of 9 times 9. So they both are perfect squares. Also, g squared is a perfect square because it breaks out down into g times g, and so is h squared. So I'm going to go ahead and split this up. And I also have to check to make sure, because it has to have that minus sign in the middle there, and it does. So I'm going to break 16g squared down into 4g times 4g, because 4 times 4 is 16, and g times g is g squared. 81h squared will be 9h and 9h, because 9 times 9 is 81, and h times h is h squared. And again, with my rule, it says I have to have a plus sign in one and a minus sign in the other to make sure that those middle terms cancel, since there's not one. So I have 4g and 4g, and then 9h and 9h. So I factored 16g squared minus 81h squared into 4g plus 9h and 4g minus 9h. So that is my correct answer. We're going to go through, this will be the last one that we check on the video. So if I'm going to check this one, if I go here, I say 4 times 4 is 16, and g times g is g squared, so 16g squared. Then I'm going to say 4 times negative 9, or 4g times negative 9h is negative 36, and I always list these in alphabetical order, so I'm going to say gh. If I go here, 9h times 4g, again, is a positive 36gh. And here, 9 times negative 9 is negative 81. Let's put that over. And then h times h is h squared. I have negative 36gh and positive 36gh, so those are going to cancel, and I'm left with 16g squared minus 81h squared, which is exactly what I started with. Please make sure that you have the work and the check for number 3 before you move on. Alright, go ahead and write down number 4. It has x squared plus 16. Alright, with this one, again, we need to look for a GCF first, but there's not one because we have an x squared and a 16. Now we need to look to see if it's the difference of perfect squares. So if we look, x squared is a perfect square. and so is 16. I can check my list in case I need to see if 16 is a perfect square. However, with this one, if you look, I said that the first term had to be a perfect square, the second term had to be a perfect square, and there had to be a minus sign in the middle. There is no minus sign here, there's a plus sign, so difference of perfect squares won't work. So since I don't have a GCF to pull out, and it's not a perfect square, difference of perfect squares, then for this one, I can't do anything to factor it. So I'm just going to write the word prime. If there's no way for you to factor something, the word for that is prime. So you're just going to write prime and you're done for this one. All right, go ahead and write down number 5. It says 9m to the 4th minus 4n squared. So again, first thing I need to do is still to look for a GCF. So I have 9 and 4, and if I check my factor sheet, the only thing 9 and 4 have in common is a 1, so there is no GCF for me to pull out. Also, I can't pull out any letters because the 9 has an M to the 4th, and then the 4 has an N to the 2nd, so they're not the same letter in common. So now I need to look, since it's a binomial, meaning two terms, to see whether it's the difference of perfect squares. So I have 9 and 4. So again, if I check my little prime factor sheet, 4 and 9 are both on here as perfect squares. 4 is 2 times 2, and 9 is 3 times 3. Also, m to the 4th is still a perfect square because it can be split up into m squared and m squared. And then n squared can be split up into n and n. So I'm going to split these up. Also check to make sure it's got that minus sign in the middle there, and it does, so I can do this. Again, has to have that minus sign. So I'm going to break 9m to the 4th up into 3m squared and 3m squared, because m squared times m squared is m to the 4th. 4n squared is going to be 2n and 2n. So I'm going to make my two sets of parentheses. Again, I'm going to have a plus sign in one and a minus sign in the other. That way my middle terms will cancel, because that's what the rule says. So I have 3m squared and 3m squared here, and then 2n and 2n. So I just factored 9m to the 4th minus 4n squared into 3m squared plus 2m and 3m squared minus 2n. And that is my final answer. Again, we're not going to take the time to check this one because we checked those first couple of ones. So please make sure you have the work down for that one before you move on. All right, go ahead and write down number 6. We have x to the 4th minus 16. So again, first thing I look for is a GCF, and there's not one. So then I look to see if they're perfect squares. X to the 4th is a perfect square because it can be broken down into x squared and x squared. 16 is a perfect square because it can be broken down into 4 and 4. And I have a minus sign in the middle, so I can do difference of perfect squares. So I'm going to split x to the 4th up into x squared and x squared, and 16 up into 4 and 4. So I'm going to go to factor this, so I'm going to write out my two parentheses, plus in one, minus in the other. So I have x squared plus 4 and x squared minus 4. Now, up until now, we were done at this point. But if you look closely at this, second one right here, x squared is a perfect square, 4 is a perfect square, and this one still has a minus sign in the middle. So I can still continue to factor this one. So I'm not completely done factoring just yet. I can turn around and break this down again into x and x. And I can break the 4 down into 2 and 2. So we have x plus 2 and x minus 2. This first one right here, I'm just going to bring that one down. I can't refactor that one because of the plus sign in the middle there. It has to be that minus sign. So I'm just going to bring it down, x squared plus 4. So this one got a little bit more complicated. We had to turn around and do the difference of perfect squares 2 times. So the first time I got x squared plus 4 and x squared minus 4, and then I refactored this one into x plus 2 and x minus 2. So this is my final answer, x squared plus 4, x plus 2, x minus 2. I am going to take the time to check this one just because it's different than all the rest of the ones that we've done. You need to know how to check it. Now, you can start with any two and start distributing. However, I like to start with the two easiest ones first. So I'm going to start here, and I'm going to say x times x is x squared. X times negative 2 is negative 2x. 2 times x is 2x. And 2 times negative 2 is negative 4. My minus 2x and my plus 2x are going to cancel, so I'm left with x squared minus 4. Then I'm going to bring this one down. X squared plus 4. And I'm going to distribute again. X squared times x squared is x to the 4th. X squared times negative 4 is negative 4x squared. 4 times x squared is positive 4x squared. And 4 times negative 4 is negative 16. My negative 4x squared and my positive 4x squared here are going to cancel, and I'm left with x to the 4th minus 16, which is exactly what I started with. Please make sure that you have the work and the check written for that one before you move on. All right, here's number 7. Go ahead and write down number 7. So again, first thing I do is look for a GCF, and there's not one because I have an x to the 4th and a y to the 4th. Those are not the same letter. Then I look to see if they're perfect squares. X to the 4th is, because you can do x squared and x squared. So is y to the 4th for y squared and y squared. And I have my minus sign in the middle, so I can do the difference of perfect squares. So I'm going to split it up and say x squared and x squared and y squared and y squared. So then I'm going to do my two sets of parentheses. I'm going to say x squared plus y squared and x squared minus y squared. And just like last time, we have to look to see and make sure that we can't do the difference of perfect squares again. I can't do the difference of perfect squares again here because of the plus sign, but over here I can still do the difference of perfect squares because x squared is a perfect square, y squared is a perfect square, and I have a minus sign in the middle. So I can turn around and refactor this one by splitting it up again and saying x times x and y times y. So then whenever I do my two sets of parentheses, I'm going to have x plus y and x minus y. And I'm going to bring this one down because, again, I couldn't refactor it. X squared plus y squared. So here's my final answer for that one. I have x squared plus y squared, x plus y, and x minus y. You have to make sure that it's completely factored before you're done. So I couldn't have stopped here because that one wasn't completely factored because I could have done the difference of perfect squares again. We're not going to check this one because we checked the last one. Please make sure you have all of the work written before you move on. All right, go ahead and write down number 8. You have 16g to the 4th minus 81h to the 4th. Okay, this is going to be the most complicated one that we do here. So again, 16 and 81, if you look on your factor sheet, don't have anything other than a 1 in common. And then, so you look, 16 is a perfect square, so is 81, so is g to the 4th, so is h to the 4th. And I have my minus sign in the middle. Always check for that minus sign. So then you can split these up and say 4g squared and 4g squared, 9h squared and 9h squared. Then when I do my parentheses, I'm going to have 4g squared plus 9h squared and 4g squared minus 9h squared. But again, I'm not finished until I look to make sure that I'm completely done factoring. This one I am because of the plus sign in the middle. But over here, 4 is still a perfect square, g squared is still a perfect square, so is 9 and h squared, and I still have that minus sign in the middle. So this one right here can turn around and be factored again. So I'm going to split it up again. This time 4 breaks up into 2 and 2, g squared into g and g. 9 into 3 and 3, and h squared into h and h. So again, I'm going to do my two sets of parentheses. 2g plus 3h and 2g minus 3h. You're going to make sure there's a plus sign in one and a minus sign in the other. And don't forget to bring this first one down. because again, I did factor that. 4g squared plus 9h squared. So this is my final answer for this one. So I factored 16g to the fourth minus 81h to the fourth into 4g squared plus 9h squared, 2g plus 3h, and 2g minus 3h. Please make sure you have all of that work written before you move on. Alright, go ahead and write down number 9. We have 4x squared plus 100. Okay. Now I know some of you are looking at it and saying, oh, it's got a plus sign, we can't do anything, so let's write prime. We can't do that because remember I said we always have to look for a GCF first. So if I look at 4 and 100 on my factor sheet, I find out that they have a 4 in common. So I have to take out the GCF of 4 first. I can't take out any x's because the 100 doesn't have one. So I'm going to say 4 divided by 4 is 1. And then bring down my x squared. Plus 100 divided by 4 is 25. So after I take out my 4, then I'll look on the inside and say, okay, can I do difference of perfect squares? X squared is a perfect square, 25 is a perfect square. However, I don't have that minus sign in the middle. Okay? So I actually have to just stop right here, and this is my final answer. It's not prime because I could factor out a GCF, and prime means you can't factor it at all. So it's not prime, but all I could do here was pull out my GCF of 4. I couldn't do difference of perfect squares because there was that plus sign in the middle instead of the minus sign. So that's all you have to do for this one. Please make sure you have that written down before you move on. Alright, so our objective for today was to factor the difference of two squares, or the difference of perfect squares. And so now you should be able to do that. So that is our objective for the day, and this is the end of your video. Thank you for watching.